Imagine a world where oceans boil into the sky, where glass rains from blood-red clouds, where the very ground beneath your feet is hotter than a raging furnace. Tonight, we're not just visiting exoplanets, we're diving into the realms of fire, death, and madness. These are the hell worlds of our universe. Earth, for all its hurricanes and volcanoes, is a paradise compared to the cosmic horrors lurking beyond our solar system. Scientists have discovered thousands of exoplanets, planets orbiting stars other than our Sun. And among them, some are true nightmares. Extreme temperatures, unimaginable pressures, chemistries so alien they make Venus look like a tropical beach. Let's start our journey with one of the most infamous of all. Kelt 9b, discovered in 2016, is a gas giant so close to its parent star that it completes an orbit every 1.5 Earth days. But here's the nightmare. Surface temperatures on Kelt 9b reach up to 4,600 Kelvin. That's hotter than some stars. Steel, vaporized, titanium, gone. Even the molecules of the planet's atmosphere literally tear themselves apart during the day, atom by atom. This is not just a scorched world, it's a place where the very concept of solid becomes meaningless. And yet, the planet endures, racing around its sun, evaporating little by little into the void. Next stop, Corot 7b, about 500 light-years away. A rocky exoplanet, roughly twice Earth's size. But that's where the similarities end. Corot 7b is so close to its star that its day side reaches 2,400 degrees Celsius. That's hot enough to melt rock. Imagine standing on a world where the ground beneath you isn't land. It's a roiling ocean of molten lava. And because the planet is tidally locked, one side always facing the star, one side always in darkness, the night side may plunge to a freezing -200 degrees Celsius. On Corot 7b, your choice of death would be burned alive or frozen solid. If you think lava worlds sound bad, just wait for this one. HD 189733b is about 64 light-years from Earth. Close, in cosmic terms. At first glance, it's a beautiful planet, a deep azure blue, reminiscent of our oceans. But the color comes not from water. It comes from silicate particles in its atmosphere. On HD 189733b, it rains molten glass, and winds howl at 5,400 miles per hour. That's 7 times the speed of sound, enough to strip skin from bone, if the glass rain didn't shred you apart first. WASP 12b is a world in its death throes. It orbits so close to its star that tidal forces are tearing it apart. This planet is literally being devoured. Its gas pulled into a giant stream that spirals into the star's fiery maw. Scientists estimate that WASP 12b has just a few million years left before it's completely destroyed, a cosmic blink of an eye. The clock is ticking, and there's nothing anyone, or anything, could do to save it. 55 Cancri A was once called the Diamond Planet. Early studies suggested it might be composed largely of carbon, perhaps even diamonds. Sounds valuable, right? But today, scientists have a far darker picture of this world. Temperatures of 2,400 degrees Celsius, violent, superheated storms, and possibly rivers of liquid carbon, molten tar, and diamond rain. On 55 Cancri A, anything familiar, land, water, sky, is twisted into something monstrous. Kepler 10b is another rocky world, about 1.4 times Earth's size, but its day side is a furnace. Scientists believe the surface is not just hot, it's broken and fragmented, like cracked glass under extreme heat. Walk across it, and you'd sink into boiling pits of molten rock. Even the mountains would be melting under your feet. You might think death would bring peace, but Kepler 70b orbits a dead star, a white dwarf, at an insane distance of just 240,000 kilometers. That's closer than the distance from the Earth to the Moon. Surface temperature? Over 7,000 degrees Fahrenheit. It's one of the hottest planets ever discovered, hotter than some stars. Here, the very light of the star scorches everything, leaving nothing but charred, irradiated rock. You might be thinking, okay, those are just a few freak examples. But the terrifying truth is, hell worlds are common. Our universe teems with planets that would kill you in seconds, not just from heat, but from acid rain, poisonous skies, crushing gravity, deadly radiation, or all of them combined. And for every planet we've found, there are thousands, millions, more waiting in the dark. Some might be even worse. But here's the strangest thought of all. Could life exist, even in hell? On Earth, we've found organisms called extremophiles, life forms that survive in boiling acid, under crushing pressure at the bottom of the ocean, or inside nuclear reactors. If life can adapt to our most extreme environments, could it find a way to survive on a lava world? Could there be creatures drinking molten rock, creatures made of exotic chemistry, thriving where no Earth life ever could? The universe is bigger, stranger, and more terrifying than we ever imagined. If you thought Kelt 9b was the ultimate inferno, meet its evil twin, TOI 1431b. This world's dayside reaches over 5,400 degrees Fahrenheit, about 3,000 degrees Celsius. That's hotter than molten steel, and not far from the temperatures at which iron itself vaporizes. Its night side, only a few hundred degrees cooler, still hot enough to melt lead. In short, there is no safe side, no cool winds, no twilight refuge. TOI 1431b is a world of endless burning. Not every hell world is a scorched wasteland. Some are trapped in gravitational nightmares. Take Kepler 36b. It shares a planetary system with Kepler 36c, two worlds so close together that their surfaces are separated by a cosmic hair's breadth. At their closest, these two planets are only about 1.9 million kilometers apart, about 5 times closer than Earth's distance to the Moon. The result? Their mutual gravity rips and tears at each other's insides. Kepler 36b may experience constant earthquakes, volcanoes, and gravitational compression. A world forever twisted and broken by the presence of its monstrous neighbor. You might be wondering, why are there so many hell worlds? How do these places come to exist at all? It all starts in the womb of creation. Protoplanetary disks, vast spinning clouds of gas, dust, and rock orbiting newborn stars. In these disks, gravity draws matter together, forming planets. But some planets are born too close to their stars, or migrate inward later through gravitational interactions. As they spiral toward their suns, they lose their atmospheres, endure blistering radiation, and suffer tidal heating that tears their cores apart. Others start out massive enough to survive, but at the cost of becoming twisted, searing horrors. Thoughtful tone. In the end, nature creates hell worlds, the same way it creates paradise worlds. It's just a roll of the cosmic dice. Many of these hell worlds are tidally locked to their stars. That means one side always faces the star, baking endlessly, while the other side is plunged into eternal darkness. Imagine a world where noon never ends, where the sun never moves from its killing zenith, where the only way to escape the heat is to flee toward the perpetual dusk of the planet's terminator zone. A thin line of twilight separating fire from ice. Even there, storms could rage forever, with hurricane winds shrieking between two apocalyptic extremes. Still hungry for more cosmic nightmares? Let's take a rapid-fire tour of some other worlds that would put Dante to shame. WASP 76b, where it rains molten iron across the night side. Glazer 436b, an icy planet where frozen gas ignites into fire due to chemical weirdness. Kepler 1520b, a planet literally disintegrating into a cloud of dust under its star's heat. NGTS 10b, a gas giant on the verge of death, orbiting its star in less than a day. LHS 3844b, a rocky world without an atmosphere, exposed naked to its star's deadly UV radiation. There are hells beyond hells, and we've only begun to explore them. Could we ever send a probe, or even a person, to these infernal planets? Short answer: number, at least not with current technology. The temperatures alone would destroy any known material in seconds. Electronics would fry. Ships would melt into slag before reaching the surface. Perhaps one day, with new materials, new shielding, and new dreams, we might glimpse these places up close. But for now they remain unreachable, the forbidden lands of the cosmos. What if somehow Earth itself became a hell world? It's not as far-fetched as it sounds. If our sun grew hotter, even slightly, or expanded into a red giant in a few billion years, our oceans would boil, our atmosphere would strip away, and Earth would become a barren, seared rock, not unlike Mercury or Venus today. Global warming, asteroid impacts, runaway greenhouse effects, all could push Earth toward a slow transformation into a miniature hell. The line between paradise and nightmare is thinner than we think. And yet, even in all their terror, there's something undeniably beautiful about these worlds. The elegance of physics, the raw power of nature. From burning skies to molten seas, the hell worlds are not mistakes. They are testaments to the infinite creativity of the universe. Terrifying, yes, but awe-inspiring too. When we gaze up at the night sky, when we dream of distant planets, let's remember, not every world is waiting to be colonized. Not every world is a second Earth. Many are hostile, deadly, merciless. But they are real, and they are part of the great cosmic story that we are only beginning to understand. In their fury, in their madness, they remind us just how lucky we are to call this small blue paradise home. Thank you for exploring the hell worlds with us tonight. If you enjoyed the ride, smash that like button, subscribe for more journeys into the strange and spectacular, and tell us in the comments which hell world fascinated or terrified you the most. Until next time, stay curious and keep looking up.